Hi there, welcome to another video from Hegarty Maths. It's Mr. Hegarty here. It's our 8th video on straight line graphs. Okay, first things first, you need to be able to work out the gradient of a line segment which has two endpoints given as coordinates. So we've done that skill previously. I want you to pause the video and work out the gradient of the line segment with these endpoints and the line segment with these endpoints. Okay, hopefully you got the following. You should have got for the first one a gradient of 3 and for the next one a gradient of 4. That's going to be an absolutely crucial skill for this particular video, so make sure you go back and sort your building blocks out if you don't know how to work those out. Next thing, these are the questions we have done so far in straight line graphs 7 and straight line graph 6. We were able to find the equation of a line passing through 0, 3 and gradient 4, and find the equation of a line passing through 2, 3 with gradient 4. Pause the video and double check you can remember how to do both of those for me, please. Okay, hopefully you got the following. The first case was really easy. If you're told it passes through 0, 3, you know that the y-intercept is 3, so c is 3. You've got the gradient, and you can just substitute into y equals mx plus c. This case, tiny bit more difficult. You substitute in the gradient that you're given, substitute in the two coordinates, the x and the y that you're given, in order to find c, and then state your final answer. Now this is what we're going to be doing in this particular skill. See how if you can spot why that's another layer of difficulty. Can you see why? Well, in this particular question, they don't even give you the gradient like they did above. So step 1, you're going to have to probably work out the gradient. And we can do that because we've got the two endpoints of a line segment. And then you're going to have to do what you did before, using one of the coordinates to find c. So that's what we're going to do in this video, and let's get cracking. Here's our first example. If you feel like you can do it, pause the video and go ahead. Otherwise, I'll go through in a few seconds. Okay, find the equation of the line passing through these 2 points and leave your answer in this form here. We don't have the gradient, we don't have the y-intercept. Let's start by working out the gradient. M is going to be our gradient. State our formula, it's the difference in y's divided by the difference in x's. So what we're going to do is we're going to say 9 subtract 3, so we're going to say that's 9 subtract 3 divided by 3 subtract 2. 3 subtract 2. 9 subtract 3 is 6, so that's 6 over 1, so our gradient is therefore equal to 6. Okay, now we can write our equation y equals mx plus c, where m is 6, so 6x plus c. And we know this line goes through these 2 points. Now we can use any of these 2 points we want. In this example, I'll use 2, 3. I'm going to substitute x is 2 and y is 3 in here to get c. So let's do that. So let's substitute that in. So we're going to have 3 is equal to 6 multiplied by 2, add c. 3 is going to equal to 12, add c. Subtract 12 off both sides. I'm going to get myself 3 subtract 12, which is negative 9. So we have c, we have m. Therefore, we can state that y is equal to 6x subtract 9, and we're done. Now, just a quick point to point out here, I could have substituted in 3, 9 if I wanted as well, this one. And let me just prove to you that I'd have got the exact same c. If I did, I would have had the equation 9 is equal to 6 bracket 3 add c. 9 is equal to 18 add c. Taking away 18 off both sides, I would have again got c is negative 9 as I did before. So either one of these can be substituted in to get your c. But there we go, we're done. And all the future questions will proceed in exactly the same way, so pause the video at each stage and have a go yourself, i.e. the next one. Try that. Okay, step 1, we're going to work out the gradient. The gradient is the difference in y's divided by the difference in x's. So we're going to say this is equal to 12 subtract 4 for the difference in y's divided by 7 subtract 5. 12 subtract 4 is 8, 7 subtract 5 is 2, and 8 divided by 2 is 4. So m is equal to 4. Now we can state our equation. So this is y is equal to, well, we now know that m is 4, so 4x add c. Okay, and we're going to substitute one of these in. I'm just going to stick 5, 4 in. X is 5, y is 4. So substituting in, 4 is equal to 4 multiplied by 5, add c. So 4 is equal to 20, add c. Subtract 20 from both sides, and I get myself c is negative 16. So now I have myself my m, I have myself my c, and I can state quite easily that y is therefore equal to 4x subtract 16, and I'm done. Okay, next one. Pause the video, have a go. Same old stuff. M here is the difference in y divided by the difference in x. That's always our step 1. So that's going to be 2 subtract 5 divided by 3 subtract 0. 2 subtract 5 is negative 3. 3 divided by subtract 0 is positive 3. And negative 3 divided by 3 is going to be negative 1. So m is negative 1. So go up here and we can state that y is therefore equal to negative 1x. I'm going to write the negative 1 in for now. Negative 1x plus c. I'm going to substitute in 0, 5. X is 0, y is 5. So 5 is going to equal negative 1, brackets, 0, add c. 0 times negative 1 is just 0. So c therefore must be equal to 5. Now we have our m, we have our c, so we can state that y is negative 1x, add 5. But we don't bother writing the negative 1 in our final answer, so as our final answer we just state y is equal to negative x, add 5, like that. Okay? And if you really wanted to, you're allowed, because that's negative and that's positive, you might be allowed to swap them round and write them like that if you really wanted to. And we're done. Next one, pause the video, have a go. Okay, m here is the difference in y again over the difference in x. So this is going to be 4 subtract 5 divided by 3 subtract 1. 4 subtract 5 is negative 1, so that's negative 1 over 2, which is negative a half. Okay, so now we're going to go over here and we're going to say okay. We can write y is therefore equal to negative a half x, add c. I'm going to substitute one of these in here. It doesn't matter which one, so let's just substitute in 1, 5. X is 1, y is 5. So 5 is equal to negative a half multiplied by 1, add c. So 5 is therefore negative a half, add c. Add a half to both sides, and we'll get 5.5 on this side is equal to c. Which, you know, usually we might write as an improper fraction. So we might write that as 11 over 2. Now we're ready to state our equation. Y is therefore equal to negative a half x, add 11 over 2. And that's the question answered. I just want to point out one extra thing that sometimes can be asked of you. Sometimes they'll say something like leave your answer in the form ax plus by plus c is 0 when a, b and c are integers. Now we've currently got, we've got y is equal to negative a half x, add 11 over 2. I'm not allowed a fraction here or a fraction here. What could I do to both sides to get rid of that divide by 2? Multiply both sides by 2. So I'd get 2y is equal to negative 1x, which I'm just going to write as negative x, and 11 over 2 multiplied by 2 is just 11, add 11. And we're nearly there now. What we can do is we can add x and subtract 11 from both sides. So we'll get x add 2y subtract 11 is equal to 0. And it's in the form requested where a is equal to 1, b is equal to 2, and c is negative 11, and we're done. And that's it for this video. Thanks for watching.